Hey everybody, how's it going? Happy Friday to you guys. Hello Mike, hello Shrek, hello Ando Bear, hello Trogdor, hello Belcut, D Stratus. I think we have emotes now. Let's see. Yeah, we have some emotes. Good afternoon, Nookus, Shaolin, Cowardly, Formula Q1, hungover, but I made it. Good for you. This is the first week of classes. What are you doing? Almonte, hello. Sleepy Apple, good afternoon. Imze, hello. Hope you guys are doing well. That's why he's hungover, duh. Get a grip. Kate, what is up? Okay, so I think you have to do... Okay, so that colon is for Discord, but on Twitch, you just have to type out... I know. Hello, Marks. Let's see. This is... So, to do... That guy who stinks, you were very close. You have to do... Yeah, there you go. You have to do that. Liam suggested Dr. Ardashir Rehanian, so I think it's this? Yes! Hello, Amin. What else do we have? I think we have a little... I think we have Wally. Yeah. Yeah. You know. Hello, Chinghan. Oh yeah, what else do we have? We have... Wait, how do I do that? Do I have better TTV? I think so. I think I have that one. Will you be adding splits to your lectures, or are we flying blind? Wait, what do you mean? You mean like timestamps? Well, if you want to do Little Wally, you get rid of the quotations. Let's see. All right, get ready, everybody. Get this handout going, because we have a lot to do. Yeah, Ando Bear is getting it. You're getting it. All right, let me just pull this up. All right, everybody. First, we're going to talk about types of signals. And we'll start here in the top left. Okay. So let's take this variable x of t and assume that it represents some physical process, and we can track it continuously as a function of time. So what you're seeing here is a situation where the independent or the dependent variable x is continuous, and the independent variable t is also continuous. And we'll do a couple examples here so you'll see the difference between a continuous variable, and a quantized variable. Okay, so let's move over. Let's do one where t is continuous, the horizontal axis, but x is quantized. So let's assume that x, it can't take any quantity. It can only take an integer value between 1 and 5. All right. So we're moving along continuously in time. And even if the x signal is deviating, we're always going to have to just throw the value in the bin that it's closest to. So like wherever x is above this halfway point, it'll just go to 5. And when it drops below, it's going to go to 4. And then when it drops below again, let's see, it's going to be 3. And I guess it'll stay at 3 all the way up until here. We can make these little halfway points to help. But you can see that t is continuous. We're getting a sample continuously as a function of time, but the x variable is getting thrown into a bin that's just an integer. All right, so maybe we won't go too much longer on this. Maybe this goes to 5. This goes back to 4. 3. This goes to 2. But this is an example of x being quantized to an integer value and t being continuous. All right, now let's switch it. Let's say that t is quantized, but x is continuous. So x can take any value. So let's quantize t at these 1 second intervals. So at time 0, we get this x sample. Here we get this, this, this. All right. So x can be any value. It's continuous. But in this case, t is quantized. I can only grab a sample at discrete points in time. Now, this last example is what we deal with in digital control systems, where x is quantized. It can only take a set number of values, and also t is quantized. So let's do that. This will be a little trickier. So, okay, so it starts at 5, so we grab that point. And then at 1 second, we grab our next value. And it looks like at 1 second, it's actually closer to 4 than it is to 5. So we would just put this at 4. And then at 2 seconds, we're going to grab another value. This is closest to 3, so it'll go to 3. Same right here. This is close to 4. This is probably closer to 4. Maybe this goes to 4, I'm not sure. Or no, that looks like it's close to 3. Both quantized, yes. Is quantized similar to piecewise function? I guess when it's quantized in x, but it's continuous in t, that kind of looks like a piecewise function to me. All right, so we have classifications for these types of sampling. So anytime that t is quantized, we call this a discrete time system. So I'm going to throw a box around both of these guys. So t is quantized in these cases, and this means it's a discrete time system. or a discrete time signal. And then this one where they're both quantized, this is what we call a digital signal. Or a digital signal will fall into this category, where X is quantized and T is quantized. All right. Let us now introduce some terminology for sampling. So let's say we have a digital signal here. It's quantized in time, where we have 0.1 second intervals between samples. And then the samples that we're getting, these are all integers. So this one's like 500, 523, and so on. All right. So let's introduce some terminology here that we're going to use for the rest of the course. So this time in between samples, this time interval, this is the sampling period. And we like to call it, we just use the variable capital T. Carl says, since difference equations resemble numerical functions, can we use numerical methods to solve? Yes. Like Newton-Raphson, yes. Difference equations are equations that I'm sure you guys have seen in one context or another before. Yeah, great question. So the sampling period is the time elapsed between samples and it's a special case actually when the time between samples is always the same. So in this case, the time between samples is 0.01 seconds. When that is constant, we call it periodic sampling. So when the sampling period is constant from sample to sample. And in practice, you actually have to enforce this with a timer. So I'll show you a code on an Arduino in a couple minutes where I'm gathering data from an accelerometer. And what I do is I build a timer into the script so that I can regulate this sampling period. If you just let like an Arduino loop run on its own and gather data from a sensor, there's no guarantee that the samples will be evenly spaced. And you might say like, well, why do I even care? A lot of the difference equation theory that we use just assumes that the sampling period is constant, and it makes the math a little easier. Okay. The sampling frequency. Usually we talk about this in hertz. So hertz is just a cycle per second. How many cycles per second? So the sampling frequency, F sub S, is 1 over the sampling period. So in this example up above, T is 0.01 seconds. So this is 100 cycles per second. 100 hertz. It's also common for us to talk about sampling frequency in radians per second. So 1 cycle is equivalent to 2 pi radians, like traveling once around a circle. So if I have a sampling frequency of 100 cycles per second, then that's 100 times I'm going around 2 pi radians per second. So if I want to do this, my sampling frequency in radians per second, and we usually use the variable omega here. It's not a W. We'll call it omega S. So I take 2 pi times my sampling frequency. And so in radians per second, this is 200 pi radians per second. That's our sampling frequency for this example. All right. So we got our sampling period, sampling frequency, and we can express that in 2 different units. And we're going to tend to use periodic sampling where we uniformly distribute our samples. Okay, so now we're going to go to an example with an Arduino just so I can show you this really quick. Okay, let's go over to this scene. Let's see if this will work. I was playing with this earlier. Oh, buddy. I think it's working. Okay, I got an Arduino Uno right here. And you see some wires coming off. What are they connected to? An accelerometer. And this camera doesn't autofocus, I think. So we have a blurry accelerometer in the foreground. And, oh, did I just unplug the power? Okay, this is a little tricksy. Okay, so an accelerometer measures acceleration. So as I move this thing around, in the bottom left of the screen, you're seeing some numbers come in. All right. Now, in the left column, you keep seeing the number 1 over and over and over again. What that number is I'm calculating the sampling period. So the time between samples. So right now I'm collecting acceleration samples at 1 second intervals. So that left column is the sampling period. This is periodic sampling. The right number is the integer value that that the analog to digital converter on the Arduino is converting this reading into. So, and we'll talk a little bit more about that below. Actually, why don't we go back here and fill in this chart? Because I think it'll make a little more sense of this. So we'll come back to this. Let's go down here. Another flow chart. All right. And this flow chart describes digital data acquisition, kind of the flow of how this goes. So here in this bubble, we have a transducer or a sensor. Benny says, gotta love them flow charts. Yes, sir. So what is a transducer? Let's make a little definition up here. It converts some physical quantity into an electrical signal. Could we create our own DAC software? You could. There's a cool video I could show you or send you the link for where you make your own digital to analog or analog to digital converter. But yeah, you can certainly build your own. Okay, so you have different types of transducers, and when we're interacting with our external environment, we have different transducers for different things. Like they react to electrical current or force or light intensity, or like a gyroscope reacts to angular velocity. And this accelerometer that I'm showing you, it reacts to linear acceleration. As I wave it around and it accelerates, it mechanically reacts, and then it converts that into an electrical response. So an electrical signal is going to come off of our accelerometer. And maybe it's like a sinusoidal pattern or something like this. But you'll notice on here, I put some like little jagged spots in the signal. And that's something to recognize. Anytime that we are dealing with transducers that convert something into an electrical signal, we're going to get noise. A lot of these jagged lines, it's not the true acceleration of the device that I mounted the accelerometer to. It might be electrical noise. Yeah. Or it could be something that's actually physical. Like it could be, okay, I have a great example. Oh, geez. Okay, this is a balancing robot that I've been trying to build on my own for like a while now. And I'm getting close, okay? But one of the problems with this thing is I use stepper motors. That's the type of motor that's rotating this wheel. The thing with stepper motors is this is Wally number 2. The thing with stepper motors is that they vibrate a lot. And as I spin these wheels with the stepper motor, the whole structure vibrates. And so I have a gyroscope mounted onto this structure, and it's sensing all of those vibrations, and that's like not the signal that I want to pick up. Looks good so far? With a question mark? What is that? Are you saying it doesn't look good? Okay, so it could be electrical noise, it could be some kind of mechanical noise. But often it's something that we don't want. All right. So that's our raw signal. Have I used the stepper dampers at all? You're going to have to tell me about those, because I don't know what that is, but it sounds like something I might need. So we're connecting the accelerometer to an Arduino. And specifically on the Arduino, at the pin where I connect this, I use an analog to digital converter. Primordial says, how do I plan on filtering out that noise? Well, one strategy is a part of this flowchart. There's different ways. Like if I could mechanically damp out some of those vibrations, that would be good. Like maybe the chassis that I built is just too flimsy, and maybe I need to make it a little more structurally solid so that it just doesn't shake around as much. But there's other things you can do. Okay, so we're going to convert this analog signal. So this analog means it's continuous in time. It's continuous in the variable itself. Like, I'll just go up here really quick. When we talk about an analog signal, we're talking about continuous in time and continuous in X, the dependent variable. The analog to digital converter on the Arduino or computer, whatever, is going to quantize that signal in both X and time. So we're going from up here to down here when we use the ADC, analog to digital converter. So that's what you're seeing here. I have that analog signal in blue, maybe some vibrations, noise, whatever. And then I convert it into a digital signal. it's interesting, this analog to digital converter. Like, this is a physical circuit, obviously, but it has some logic built in there, and it's always taking in the sample and making some comparisons and saying, okay, which bin is appropriate? Like, what discrete level is this voltage closest to that I can throw it in? You can see that on these labels, I put a range of 0 to 1023 integer values. So it's always being sent to an integer value in between there. And you'll see why I picked these numbers in just a second. Okay, let's just finish this little flow chart here. So let's say I want to get rid of some of this noise. So what's common is to use a digital low-pass filter or some variety of low-pass filter. What a low-pass filter means is I only allow low frequency 2 to the 10. Dark Stratus knows what's going on. Low pass means I only let low frequency content come through. That's not totally true. I mean, every frequency is going to come through, but the high frequency stuff like this noise, the amplitude of that when it goes through this low pass filter, the amplitude of the high frequency stuff is going to be squashed. It's going to be attenuated. And when it comes out the other side, you're not going to see those spikes anymore, depending on how we design this filter. So that's kind of the signal flow. Yes. The way to understand a low-pass filter, Mike brings up Bode. A Bode plot is the way to understand it. And we can talk about that more down the line. So we have sensors monitoring our external environment. They're transduced into an electrical signal. The Arduino converts that electrical signal into a quantized digital signal. And that's what we're going to use in our control systems. Because remember, a basic feedback control system, it measures some quantity that I want to control. It compares the measured quantity to the desired quantity. Like, what do I want this thing to be at right now? I calculate the difference between the measured and the desired behavior, and then the controller moves from there. Okay, so now we'll come back to this. The low frequency signals still technically come through. Yes. The whole signal comes through. Yeah, the high frequency still comes through. Like, really quick. This will take like a couple, like maybe a minute. But we know that any signal, like let's say this is a signal. We know from our good friend Fourier that I can break this signal into a superposition of different sinusoids. So maybe you can see that this low frequency sinusoid kind of fits. And then on top of it, if I add like a really high frequency sinusoid, this pink line plus the dark blue line superimposed, it'll add up to this like light blue line, right? So what a low pass filter does is it preserves the amplitude of the low frequency stuff, the content that's low frequency, but the high frequency content right here, I don't know, like originally it has an amplitude like this much. That amplitude gets squashed. So it's not like it goes away, but the amplitude shrinks so that you don't see it so much in the final product. We call that attenuation. Okay, let's come back over here. Maybe we'll go to the code really quick. All right, here I'm defining my desired sampling rate. Okay, 1 hertz. That means that my desired sampling period is 1 divided by that. And this is the pin on the Arduino, analog 0, where I'm reading this axis from the accelerometer. And then this is going to be stored in a variable which I call sensor value. What was attenuation again? Attenuation is when the amplitude of a signal shrinks, is made smaller. Doesn't make the signal go away. All right. So let's increase the sampling frequency. Let's do 10 samples per second. Now I'm moving it back and forth, and you see the sampling period on the left-hand column, it went down to 0.1. Let's increase it even more, 100 samples per second. Uh-oh. Blah, 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 blah. And you see it's going to an integer value. So let's talk about that integer value. This Arduino board has a 10-bit digital to analog converter. Let's talk about what 10 bits means. When you're increasing the sampling rate, are these sampled periodic samples? Are they all taken at a constant rate, or can they be in any time frame within the 1 second? Excellent question. They are periodic samples. And I'll show you in the code exactly how I make sure that it's periodic. Okay, so 10-bit stands for 10 binary digits. And this is where the bit comes from, the BIT, which from Wikipedia I learned that that's called a portmanteau. When you combine words like this, binary digit to bit. Now, a binary digit, what is that? It's just it's a 1 or a 0. That's what a binary digit means. So if I have a 10-bit digital to analog converter, that means the board uses 10 binary digits. Jack says every bit either 1 or 0, thus doubles the possible signals. As a result, a 10-bit board has 2 to the 10th possible outputs. Yes. So this uses 10 bits to represent a signal reading at any time. So I think we left off at 100 samples per second or 10, I can't remember. But every sample that comes in, I'm going to convert it into a number, a sequence of 10 binary digits. 1, 2, I'm just making something up. That's 5, 6, 7, 8, 9, 10. So maybe the sample that comes in, it gets assigned this number with the digital to analog converter. And if you think about this, there's only 2 to the 10, or which is 1024 combinations that are possible, because we're only working with binary digits, zeros or ones. And if I only have 10 bits to use to encode some value that comes in, a voltage, there's only 1024 levels or combinations that I can possibly attribute to. So on an Arduino, each input pin, the pin accepts voltages between 0 and 5 volts. So this is quantized to integers 0 to 1023. And so 0, 1, blah, blah, blah. If you count all the way up to 1023, that's 1024 possible numbers. So when I'm waving around this accelerometer, the transducer is producing voltages in between here. And then as those voltages are received by the Arduino, it encodes each of them with a binary sequence of numbers. And that is converted to just whatever number. I mean, there's only 1023 of these combinations. So that's what you're seeing. That's what you're seeing here on the left. I'm shaking this around and this is converting it, looks like 100 times a second, into a number between 0 and 1023. And actually, this is only a 3 volt sensor. So that's why the number, you never see it go up to 1,000. It only goes up to like 600, because that's 3 out of 5 volts. That's like 600 out of 1023. That guy who stinks says, does that mean if it was a higher bit board, we would get more precision? Yes. Like if this was a 16-bit analog to digital converter, that's 2 to the 16. What is that? I have no idea what that is. But that's many, many more levels. And if you've heard of like 32-bit, 64-bit, 65,000. Okay. So yeah, it's much, much higher resolution, much more precision. Let's see here. Oh, right. I wanted to tell you, yeah, Nintendo 64. What does the 64 stand for? 64-bit. How is the voltage related to the integers that you're getting? Oh, great question. Let's draw that right here. Actually, I'm going to do this in a table, actually. We'll do voltage. And then we'll do the integer over here. So if I have 0 volts coming into that pin, it assigns the integer 0. And then let's skip down to the end. The highest that I can get is 5 volts. That corresponds to 1023. And then all of the levels in between are just linearly distributed. So now I'll make a graph actually. So let's make this graph the integer 0 to 1023. Or no, let's go the other way. Let's make this horizontal axis 0 to 1023. And then this axis goes 0 volts up to 5 volts. And we connect these points with a line. So if I'm getting a number that's like 600, we were seeing that coming up sometimes, then you follow that across. And I could be like, oh, that's, I don't know, that's 2.5 volts or something like that. So I could build a line into my code that does this conversion for me. And that's what calibration is. Calibration is the conversion of some quantity into another. It's when we're talking about sensors. So I could have a calibration equation that results this integer to the actual voltage. And then you have a further calibration, because if you look up the data sheet for this sensor, oh, I can't remember. I'm just going to make something up. Like it might be 0 volts is 0 meters per second squared of acceleration, and maybe 3 volts is like 5 Gs or something. So like 5 times 9.81 meters per second squared. Something like that. So this is how you eventually relate it back to like, okay, how was this accelerating? I had thought that 1023 responds to the possible combinations. If we had 600, does this mean there are less possible binary combinations during that sample? Oh, no. So, okay, so the digital to analog converter on the Arduino, each pin quantizes, it can receive up to 5 volts, and it'll quantize those voltages. Now, the reason that this accelerometer only like hits a number like 600 is because this sensor only receives and outputs up to 3 volts. So actually, like, just a consequence of this sensor being a lower voltage sensor, I guess you could say that the resolution is poorer. So I guess you're right. I guess there are less possible combinations for this sensor just because its voltage range doesn't go over the full 5 volts. The weakest link of a chain. Yes. In this case, the accelerometer is the weakest link. Are higher quality sensors higher volts? I don't think so. I think usually a sensor is between 3 and 5 volts, but you have a nicer data, or you have a higher bit board. Because think about it, like this 3 volt sensor, if I had a 16-bit board, that would make a much bigger difference in terms of resolution. Will the voltage be constant? The voltage supplied to the sensor is constant, but the voltage that comes off of the sensor changes depending on how it reacts to the external environment. Like, it wouldn't make sense for the accelerometer to constantly output 3 volts. Like, the electrical signal should change with physical quantity. Oh yeah, I wanted to show you the timing. We won't spend a lot of time here. Wait, I want to do this one. Okay. Where'd you go? Okay, so what I do is, so I have this desired sampling period, which I called T desired. So I have this if statement in the code, and I say if the sample, or if the time that has passed from the last sample is bigger than the time that I want between samples, only then do I grab another sample. So basically, all this code is saying is like, okay, you took a sample. Okay, now you have to wait until this amount of time has passed, and then I'll allow you to take your next sample. So I use an if statement, and I'm just constantly monitoring the amount of time that has passed. Is there a way to change the range on the Arduino to 0 to 3 volts? That might be possible. I'm not that advanced with Arduino to know the answer to that question. I'm trying to better understand what the integer means. So if I have a 10-bit board, but it is only receiving 2.5 volts, so has 600 as an integer, the binary code will have less than 10 values of either 1 or 0. Sorry for so many questions. No, I wouldn't say that. The binary code will have less than 10 values of 1 or 0. No, because every integer let's see. Every integer between 0 and 1023 still has a 10-digit binary number that corresponds with it. Like Dark Stratus is throwing some 10-digit number in there. That corresponds to an integer. So every integer between 0 and 1023, one is 00001 in 10-bit binary. Thank you, Mike. Beautiful. Yeah, I know. You can ask me more questions on this, but I know we're running out of time, but I want to introduce this problem, which we'll have to pick this back up again on Monday. So we'll reintroduce this on Monday, but you can start right now to think about this problem. It's kind of fun. And okay, let's just introduce it. This is Fibonacci's rabbit population model. H-Dog says, where can I donate? There's no donations for this channel. It's all free. I appreciate it though. So this is how it goes. These are the rules. A single newly born pair of rabbits, one male, one female, they're put into a field. And here they are. They're babies, and they've been introduced to the field at month 0. All right. Okay, rule number 2. Rabbits are able to mate at the age of 1 month. Here you can see those same rabbits. They've grown after 1 month, and now they're able to mate. And let's presume that they do. So then, at the end, 2 rabbits is not enough genetic diversity to repopulate. Don't say that. So that at the end of the 2nd month, a female can produce another pair of rabbits. Yeah, not with that attitude, Weiss. Okay, so at the end of the 2nd month, we now have a newborn pair of rabbits, and you can see they're smaller. And the parents lived on. Rule 2.1. Yeah, anything is possible in digital systems, okay? Now here's the freaky property that you just have to accept, and that's that rabbits never die. You might have thought that rabbits die out in nature, that predators prey upon them, or maybe they die of old age or natural causes, but that's not the truth of the situation because they don't die. All right, they never die, and further, they always continue to mate, no matter how old they get. So the mating pair, it's always producing one new pair every month. So you can see that this pair, they had a baby in the 2nd month, and they're also producing a pair of babies in the 3rd month, and then they live on, and then they produce, and their children are growing up, and they're producing, and this is just how it goes. This is the rule. I saw rabbit tracks yesterday. See, rabbits do exist. That proves my point. That guy who stinks says, so this is the sum of primes up to the 12th prime number. I don't know. I just don't even know. So here's your task. Here's your task. And we'll come back to this on Monday. How many rabbits will be in the population after 1 year? So think about how you would solve this. I mean, you could draw out the rest of this. I would be very impressed if you continued. That guy who stinks. I think I coded this problem in C++. Very nice. So think about how you would solve this, and then we'll go through the solution on Monday, and then we're going to talk about if there's a sophisticated approach to solve a problem like this. And this is very much related to digital controls. This is our first study of a difference equation. You'll see. And with that, we're going to conclude our week. I know Kate asked earlier about the first homework. The first homework is related to this stuff that we're going to start on Monday. My plan is to get that homework out to you tomorrow, so you have it in advance. But the content we'll be covering throughout next week, and it'll be a joyful process. I look forward to it with you guys. Let's see the emotes here. Will this lecture be posted today? Yes. The lectures are automatically loaded on my Twitch TV videos tab. So you can even see the 2 previous lectures from this week. And then I've also been uploading these to YouTube. So you can find them on YouTube. Trogdor says, by any chance, have you had the opportunity to post the filled out lecture notes from earlier this week? I didn't see it. You're right, Trogdor. I didn't post those yet. I'll get those up. I will get those up. T. Jackson, we come back here for 3:34. That is correct. We're going to be back here. Wait, when is that lecture? It's like in 10 minutes, 20 minutes? 20 minutes. So we're going to be back here for 3:34 in 20 minutes. Hey, have a great weekend, Mike. Wow, first week of spring classes is down. And that means we have 14 more, including finals week. But we don't have a final for this class. Hey, Belkit, have a great weekend. I mean, 14 more weeks, yay. Yes. Yeah, it's 14 more straight weeks. Yeah. We'll try to work in some breaks. We'll see how everybody's doing. Yeah, I'm not happy about losing break either, Kate. Quaron, you have a great weekend. We'll make it through. Dr. E should add a puggle as an emote. Yes! Oh my goodness. I have been remiss. Is 334 another DSP class? What is DSP? 14 week, 19 credit death march. Oh. It does have digital signal processing in it. Yes. Hey, welcome. I am a Toasters. You are very welcome. Yeah, we'll have some digital signal processing in that class as well. Check out stepper dampers if you have a chance. They work surprisingly well. Thank you very much, because I've been thinking about that and I really need something to help. Yeah, I appreciate that, Squiggly Toad. Hey, thank you, Brandon. See you next week. Along with micro stepping, you could probably get it super smooth. Right, okay, so I've been trying some micro stepping, right? Because that makes it smoother. But then the problem I ran into is, so originally I was using the digital write command to send pulses to the stepper motors. But that command is slow, apparently. And when you use micro stepping, you have to send faster pulses. And so now I have to start getting into port manipulation. And that's, so that's kind of the next thing I'm getting into. I'm a little bit of a newbie with like the port manipulation and the playing with the clock and the pre-multiplier and blah, 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 blah. H. Swan, have a great weekend. Thank you. All right, everybody. I need to run, but we're going to be back here in 10 minutes for MAE 334. Hey, take care, Squiggly Toad. I'm going to grab a snack. Pika Pika, thank you very much. Wait, is the sun out? Benny says at 12 months, 233 pairs of rabbits. Let me check. I got a different number. What is MAE 334? What class? That, the name of the class is MAE Lab 1. It's kind of a very vague title, but what it's about is, it's a lab course, so it's experimental analysis of dynamic systems. So it does have data acquisition. It also has some info on microcontrollers. It's a fun class. I'm looking forward to it. All right, everybody, I gotta run. I gotta get a snack. See you in 10 minutes. Hey, how's it going, everybody? Welcome to MAE 334. Hope you guys are doing all right. How do I donate? Says OGS Cap. There's no donations. There's no subs. It's all turned off. This is free. This is free. There's no ads. There's none of that. MAE Pog. No, you can't pay me. No. We have some emotes for the channel. Let's see. I don't know. We got like the space buns right here. What else do we? Yeah, there we go. We have like the Gandalf. Yeah, there's a couple emotes. If you guys have emotes ideas, you can put them in the Discord. Dr. S says, GME going to the moon? Yeah, I mean, diamond hands and all that, right? Never coming back down. Sponsored by Simply Safe? Yeah. Actually, we're sponsored by Nalgene. Sponsored by Nalgene. Root, just stopping by to say hi. Do you remember me from Flight Dynamics? Yes, I remember you. Thanks for coming. I'm doing well. Can I do a Pogger's face? Wait, is that like the surprise? Like, that's my Pogger's face. I'm not totally up on the Twitch lingo. I know some of it. Gradually learning. First time on Twitch, says Paul Capo. It's fun. I like the Twitch environment. It's like, it's laid back. It doesn't seem to have so many bugs so far. I'm eating lunch while doing this. Legit got no time to eat. Yeah. Me neither on Fridays. What influenced you to do Twitch? It's unique versus Zoom and WebEx. Well, because I figured that a lot of you already use Twitch anyways. So you're familiar with the platform. And I just think it's It's different. It's fun. We do a lot of Zoom. We do a lot of WebEx anyway, so I just wanted this to be a little bit of a different platform. I'm a toaster says Zoom is an awful product. I mean, I wouldn't say it's awful. I prefer this for classes. Estes uses Facebook Gaming to stream next semester. Yeah, that's what we'll be doing. Twitch got to get on the online education train. Twitch Education Edition. I heard that they might be making an education category. Right now it's just like science and technology. Can you give us a rundown on what we should have done by now? We can talk about that. If you haven't done anything up to this point, that's okay. Actually, you need the kit. If you haven't ordered that kit, you gotta get it. Education is fine as all, but when are we playing video games? Exactly. Right now, I'm playing Breath of the Wild on Switch Lite. I'm enjoying it so much. Omni Zenith says kit acquired. Very good. Very good. Okay, how about we... Yeah, Breath of the Wild is out of control. The purpose of this class is to make your own Arduino video game. I guess you could. How about we talk about the class? Dr. S's dearest respect for allowing an open chat for undergrad students, the most immature people on the planet. Thank you. Oh, come on. You guys are doing very well so far. I think you're respecting the rules. I think you're doing great. We need to change this title because I just had digital control systems earlier. MAE Lab 1. MAE Lab 1. This is what we're doing right now. And the date is the 5th. It is not the 3rd. Let's get that changed. Friday, 2/5. All right. I see some questions. Were we supposed to do something this week? You don't need to do anything up to this point except have the kit. But we'll get into this. When it comes to in-person workshops, labs, will there be computers to do the code? There are some computers in the lab, Furnace 810 and Furnace 811, but we won't have a computer for everybody. So I think that it's important to bring your laptop, if you can, to the on-campus lab sessions. Is the CD that came with the kit necessary to use? I do not have disk drive on my computer. No, you don't need that CD that came with the kit. Can you give a better description on how to download Arduino? We can get to that. We'll get into all of this. We'll get into all your questions. Let's just first talk about a broad overview of the class. Like, what are you getting into? All right. So welcome. So I'm going to sum up what MAE 334 is. So this is no longer 444. This is 334. Or is it? No, it's not 344, right? There's two. It's 334. I'm going to sum up what this class is in a sentence, and then we'll talk about it a little more. So you can follow along. You can write along with me. This is a lab course on the experimental analysis of dynamic systems. And I wouldn't leave it just right there. I'm adding, we'll have this and the basic usage of microcontrollers. So if you ask me to sum up this course in a sentence, this is what Jean-Claude says: dynamic systems like blinking LEDs. Okay. I mean, that's not quite a dynamic system. It's not the most dynamic of systems. Okay, so yes, I see somebody dropped the MOOC in the chat. Did you guys, how many of you took dynamic systems with MOOC? That's how you say it, right? I love Dr. MOOC. I look up to him immensely. I think he's a guru. He's a guru of dynamic systems. Very nice. Now, did he tell you about that landing system that he developed a control system for jets landing on aircraft carriers? I think he usually tells that story, but I mean, it blows my mind. Blows my mind. So dynamic systems. So we're talking about content from MAE 340. So a lot of stuff that you saw in that class, you're going to see here again. Berserk says, MOOC scares me. I think he can be, I mean, he's very cool. It can be a little intimidating too. Definitely agree. So first order systems, second order systems, and higher order systems. We're going to take some looking at. I feel robbed by Mook. He said he would show off his car skills. He never did. Wait, what car skills? Is he like a rally driver or something? Does he drift? And we're going to look at mechanical and electrical systems. You're going to see things like the step response in an experimental setting. You're also going to see frequency response. Bodie plots of real systems. He drives a Honda Odyssey, LOL. I've seen him in a minivan. I've seen it. Mooks and Formula Drift, yeah. I think so. Okay, so you're going to see this content. All right, this is a lab course. So I got nothing against Honda Odysseys, by the way. So this is hands-on. Even if you're a remote online student, we have hands-on for you. A lot of hands-on experiences. So we're going to do, I mean, you have to learn the lingo. We're going to have 7 workshops, 3 labs, and 3 assignments. So those are like the 3 categories of things that we're going to do. So for the workshops, this is why you need that kit. If you don't have that kit ordered yet, you got to do it. Jern Binks says, will you be present for in-person labs? I will not be present for your in-person labs. You're going to have a teaching assistant who's present. How do labs differ from workshops? Okay, so the difference between a lab and a workshop is that the labs require a lab report. And we'll talk more about this, like the exact format, like it has an abstract, introduction, the experimental methods, and so on. And you're going to write this lab report with a partner. I Love Salami says, I was kind of confused looking at the class schedule. Is this the only class we have in the week for 334? That's correct. We're the only time that we're going to, actually I won't say the only time because I have something in mind, but our lecture is only on Fridays. And the reason I say I don't think this will be the only time that we'll be able to meet is I'm thinking about doing, probably on Monday nights, like a live workshop session where if you're an online student and I don't know, you want to do the workshop kind of in community. I was thinking of being on Twitch at some time in the evening and having the kit and plugging things in and so you can hang out and if you want to do the workshop at the same time as some other people. And I can take some questions and stuff. So that's my idea. Abel says, is this recorded and posted on YouTube? Yes, it will be. How extensive are the due dates for these assignments? What do you mean by extensive? Sean Class says, no, I'll just keep hitting you up constantly on Discord. Yeah, if you haven't been to the Discord yet, it's great. Probably many of you are familiar with Discord. It's just like a, how would you describe it? It's like a chat space. It's kind of like Zoom as well because you can have video conversations. You can share screen. AOL, it's not like AOL. Modern... AOL isn't even a thing anymore, is it? Good grief. AOL Instant Messenger? So, if you haven't been to the Discord yet, check it out. And I've already seen people posting questions on the first workshop. People are helping each other, and that's what the Discord is for. That's why I said modern AIM. Okay, sure. AOL will live forever in our hearts. Yeah, okay, sure. So the Discord is a good space. So yeah, the difference between workshops and labs, the workshops are going to use the kit exclusively. And can I use the Pony Express? Sure. You can send snail mail via a caballo. That's okay. And for the labs, these are going to use equipment on campus other than the kit. So like, for example, for the third lab, we have this flexible beam that we're going to get the frequency response of. Isn't the kit the car from Knight Rider? A different kit. Okay. Now assignments, what's the difference between assignments and all this other stuff? For assignments, even if you're an on-campus student, you're not going to meet on campus on those weeks where we do an assignment. An assignment, sometimes it's going to look like a workshop where you're going to have to assemble some stuff with the components from your kit. And like Lilkev699 says, so if we're online, we just get the lab data sent to us. That's correct. If you're an online student, you're not going to be able to conduct the lab experiment yourself because that equipment is just on campus. So you're just going to have data that we provide for you. And the assignments, they're also going to require some more written responses. Like for the workshop, if you're an online student, you're going to complete the workshop. You're going to document your completion of the workshop with a video and some time-lapse recordings. And you're going to say some verbal explanation of what you're doing, but you don't have to submit like an in-depth report. It's kind of minimal. Do I expect both students to get the same grade? in the end. Are you talking about on campus and online students? I think the experience overall is pretty equitable. Okay. So lab course, dynamic systems. Let's talk about experimental analysis really quick. So we're going to be talking about data acquisition in this course. And we're going to be performing data acquisition. So we're going to be working with different sensors. We're going to talk about digital to analog conversion, which is a part of any time you're gathering data from sensors using a computer or microcontroller. There's going to be some digital to analog conversion. We're going to talk about sensor calibration, signal conditioning, like how do we deal with a very noisy signal coming off of a sensor. And we're also going to talk about some measurement uncertainty. So all of that stuff that goes with experimental analysis. So, and the component of the course that I think I get the most excited about, maybe some of you as well, is that we're covering some basic usage of microcontrollers. So what can you expect to see? We're going to talk about programming Arduino logic. We're going to talk about, can we wait until our lab time to partner up? Yeah, if you're an on-campus student, you can just wait until your first lab meeting next week, and you'll get to meet the people in your lab, and you can find a partner at that point. Okay, so programming a microcontroller, getting inputs. I mean, like hooking up a sensor, getting measurements. I saw that somebody on the Discord already hooked up the temperature sensor, hooked up the display. So I know a lot of you are already getting familiar with this. Like the kit comes with some exercises and some like tutorials that you can go through. It's pretty cool stuff. And we're going to talk about commanding outputs. So we're gathering sensor data, that's inputs to the microcontroller, and then we're going to also command outputs. We're going to look at how you control a couple different types of motors. The first workshop is, you know, turning on and off LEDs. So we're going to, that's where we're going to start, LEDs, but then we're going to go to DC motors, stepper motors, servo motors. And I'll tell you why this is my most favorite part of the course. If we are online, do we have to meet up with our partner? No, you don't have to meet up in person. I would suggest meeting up on Discord or Zoom or whatever you prefer, because you have to communicate with one another. The workshop one is uploaded on UB Learns. If we are in person, should we print it out and bring it to lab? Eric, that's a great idea. Yes, I would print it out and bring it to lab. But you could also, if you don't print it out, you could access it via UB Learns while you're on campus. Like, I would suggest bringing your laptop to the workshop so you could pull it up there as well. I'm an on-campus student, but I think I'm signed up for online. Should I try to switch to an in-person lab? It's up to you. It's totally up to you. Are the motors going to be brushed or brushless? We're using a brushed DC motor. Where do we turn in the video submissions again? Great question, Richard. So I'm going to post an example submission, but you're going to submit to UB Learns, and it's going to be basically, I want you to upload, if you're an online student, you're going to document your workshop with a video. I want you to upload that video to YouTube and then just send us the YouTube link. I think that's the easiest thing. Are the labs streamed? We're going to make videos of the 3 lab procedures and post that for online students to see. Course documentation said N95s will be provided, but we're only allowed to wear the one provided for 334. Does that mean we will be kicked to the curb if we show up with a different N95? Okay, the thing about that is that, like I said in the announcement, if you're on campus, it's very important that you have an N95 mask, because there's going to be times when you're moving around the lab, you might be less than 6 feet from a lab partner, all right? And so we wanted to increase the safety of the lab, and that's why we're using N95. And so we're going to give you an N95 mask that we want you to bring each week. Now, I want you to keep using that N95 mask, because if we don't do that and you have like a different mask and you're like, no, this one's good, and like I can't personally verify each mask. And I mean, maybe your mask is fantastic, but this is my way of controlling the type of mask that everyone has, so it's just uniform and we don't have people with different situations. So I would say, even if you have your own space helmet, I've known somebody who like wears this space helmet, not a mask. It's impressive. But even if that's the case, just wear the N95 mask we have for you. If we have in-person labs, do our partners need to be from the same lab session? Yes. Wear a Halo helmet? Yes. A human-sized hamster ball? Yes. That I will accept that. That is perfectly acceptable. Good luck fitting through the door. That's a good point. Okay, so this is our basic description. Now I want to tell you why I think this class is important. Why I think. And I'm going to draw a picture for this. And you're going to be very impressed. Brushed motors garbage. This message was paid for by my brushless motor gang. Very nice. Okay, this right here is you. All right. And we are, at least right now, in this remote learning environment. Jernbink says, "Where's my arms?" Built like a baked bean. I'm okay. I've seen that TikTok with the bean. Okay, so that's kind of what we're going for. All right. Looks like the dude looks like an IKEA chair. All right. So I know you're impressed. Can I commission you? Yes. Okay, and so we're taking online classes, but mostly in our education we're engaging with theory. All right, and so I sent some videos, maybe a month ago or something, showing different projects that you can do with an Arduino. So like one of those is like an automated garden. So we're gonna draw a flower here. For workshops, do we do them individually? Yes, we do. Although, I mean, like I said earlier, I think it's great to like do it in community with others, get on a Zoom call, or like I said, I plan on doing a Twitch session during the week where we can kind of do the workshop together. Okay, so and then this is like an automated garden, and maybe it regulates the water that this plant gets. All right. So if you're like me, you might look at that over there, and this is supposed to be a light bulb. I know it doesn't really look like a light bulb, maybe. You see that, and you might think it's cool, or you might have any number of projects that you want to do, but you look at that and you think, like, I don't know the first place to start. And I think that discourages many of us from trying any of these projects, because we think like there's some initiated knowledge that I just don't have. Okay, we're gonna change it to a concerned face. Was that guy who wore a space helmet named Shane, and did the mask look like that of a video game character? I don't think it was. I don't think it was Shane. Some of you have already started playing with Workshop 1, but I think as you go through this course, this is why I think this course is important. I hope that you discover, and I think you will, that you are capable of taking on projects. You're capable. Because I think what we need is just knowledge of the first couple steps, and then once you start having some success with it, you find out that you can give you can do it. So this course is going to give you some ideas of where to start. So I mean, we're doing 7 workshops, like 3 labs. You're going to work with some different equipment. You're going to do some different programming with a microcontroller. As you go forward in your engineering career, I think you're going to be able to look back, and you're going to have just some idea when you're working on a different project of like, where do I start? And like, what equipment do I need? Okay, so let's make some like steps along the way. Like, let's say you want to do an automated garden or whatever. There's many steps along the way, but anytime you take on a real life project, I think what you find is that, okay, first step, okay, I got my Arduino microcontroller. Step 2, I picked up some sensors and like a power source. Step 3, okay, I need to pump some water through here. Okay, how do I do that? Well, okay, I got to go back, Google some stuff. Step 2, figure out how water works. Yes, exactly. How do plants interact with water, and what do they need to grow? And okay, and then you come back and you're like, well, I learned something, and that's step 4. And that's how these projects go. And there's many, maybe you get to step like 126 before you get something that really works. But when you go through these hands-on projects, I think you get the opportunity to learn that, or at least you get an appreciation for the interdependence of theory and real life, and how like they reinforce each other. Jean-Claude, what's the K value of the faucet? Yeah. Death Grip says step 127, despair. No, really, despair is a part of the process. So I'll share you a little story. So, okay, I sent you guys a video of a self-balancing robot. That was one of the the videos, right? I saw that video and I was like, dude, I want to build that robot because it's so cool. It's so great. And so this is, maybe that started 2 years ago. Despair comes between the steps. Yeah, so at first I thought, okay, you know, I know what parts I need to buy. I've done some stuff with Arduino. I can put this together in a couple weeks. And I found out, no. Anytime you embark on like a real life robotics or just whatever real life project, and anybody who's done lots of projects, you know that there's always like 10, 20, 30 more steps that you didn't anticipate. Like, for example, these are stepper motors, and we're going to learn about stepper motors in this class. But one problem that they have is that they tend to vibrate as they rotate. And so when I was trying to actuate these wheels, the whole structure kind of vibrates a little bit, and it shakes the sensors on here. So if you want to balance a robot, you need a sensor that measures how the robot is tipping. And a sensor that you can use for that is a gyroscope. It measures the rate at which something is rotating. And so that's what I had on here. I don't think it's on here right now. But anyway, the vibration of these motors was shaking the gyroscope that I was just getting garbage data off of it. Turn it on. It's not even connected, and it doesn't work. So the reality is, I'm still working on this. I haven't finished it yet. It's close. It's close though. Erebus says inverted pendulum. Yes, or you could refer to this as a mobile inverted pendulum. Death Grips Pog says reduce the noise. Yes. So when you run into that problem in real life, you figure out, okay, I need a way to get rid of the noise in my signals, or I need to be able to reduce the vibrations of this structure. And if you just work on this problem on paper, you might never encounter those things. And that's the way it is with any real life problem. You run into all this stuff that you didn't even realize, and it makes you keep going back and forth to theory and so on. But all that to say, I'm definitely, my personality is, I'm comfortable living in this realm of theory, and I often get intimidated by looking at a project, and the more that I've done stuff like this, it makes me really excited about it. And I think as engineers, we, to be really great engineers, you have to kind of live in both worlds where you're going back and forth, because the real life and the theory really need each other. And I know some of you are like a different type of engineer where you're always tinkering, you're taking stuff apart, you're building stuff. And maybe you're a type of person who needs to also spend some time with the theory. Josiah says that was a really good point about importance of hands-on projects. Hey, thank you. I'm sorry, you might have said, but how long did it take you to build that two-wheeled robot? It's kind of gone in fits and starts, and sometimes I just put it down for months at a time. But like actually assembling it, once you have the parts, that's something you can do in a day. The programming, that's a little tricky. But I mean, I've been working on this thing off and on for 2 years. Not like full time. I mean, everybody has like projects going on the side, but it's hard. It's difficult. Okay. Let's see what I wanted to say next. Are the Mondays workshops that you mentioned for all students? I signed up for Tuesday morning lab. Okay, so I was mentioning earlier, if you're an online student, or for that matter, any student, I think I'm going to have a Twitch session during the week where I'll kind of go through the workshop and just be live. Like I won't go through everything. Like if you've looked at workshop 1, part of what you need to do is change the code to give it slightly different functionality. And that takes some time and some thinking to figure those things out. They're not always straightforward. So I'm not going to give you the solutions to those things. This session is more like I'll give you pointers on like, this is how you hook this up. Maybe if you're having this problem, this is how you troubleshoot it, and that sort of thing. They have stepper motor dampers for 3D printers. Somebody mentioned that in the earlier class today, and I need to look up stepper motor dampers because I think that would solve a lot of my problems. Okay, so this course is a launch point for many projects. I had a student who took this class 2 or 3 years ago, and then she went on to be she went into the master's program at UB, and I got to go to her master's thesis defense. But she developed a CO2 monitoring system for patients that are under anesthesia. Because when you're when you're put under for an operation or something, that's something that they have to monitor. But she used principles and skills from this class to actually build this data acquisition device. So it had an Arduino, it had some solenoid valves, ran on Arduino, some relays. So this is stuff you're going to learn about, and that's why I say like it's a launch point. It gives you some first steps for many projects down the line. Also something to keep in mind, you're going to be taking your Capstone project as a senior, and maybe I know many of you are seniors right now, so you might be in the Capstone course, but when you're thinking about doing your senior project, you can I think it was last year a team made an automated French press. So for all you coffee lovers, and for you coffee snobs who think the French press coffee is always better, they made an automated one. They used Arduino to do everything, and some like solenoids, some different actuators. Some Capstone group, they built this robot for removing a dish from the oven. So that's something to keep in mind too. Can I set it up to use the James Hoffman French press method? I don't know the Hoffman French press method. And then for those of you interested in control systems, robotics, this is just a great starting point for that. Tommy says, would you suggest keeping our codes on a flash drive? You could. Like, okay, so if you're an on-campus student, somebody asked me, like, can we work on the workshops in advance of when you actually meet on campus? And I think that's a great idea. And if you want, you could even, if you have time during the week, you can make your codes in advance. And so you could come to your workshop session and basically assemble everything step by step there, have it ready to go, and you can have the teaching assistant check off on that. So that is a way you can approach the workshops as an on-campus student. I thought this was a Fortnite stream. That's coming up. That's coming up next. All right, guys, let's go into the syllabus. I mean, we've been talking about, just for the rest of the time, when is this over? Is this over at 2:40, I think? I just want to spend the rest of the time going over the format, answering any miscellaneous questions or concerns that you have. Okay, 2:40, thanks so much. And so I'll just kind of go through here step by step, and you just throw questions in the chat as they come up. Okay, so we'll be here on Fridays. This lecture wasn't on my schedule. I just saw the UB Learns announcement. Okay, great. Glad you saw that. I would say get on that Discord server. I think we're building a cool little 334 community, helping each other out. So I'm really happy to see that. I already talked about in general what we're covering, so I think you have a good idea of that. And this table just goes through, we have certain learning outcomes for our MAE program, and this is how the course is linked to those. So make sure that you purchase this starter kit. If you haven't gotten it yet, the link is on UB Learns. I'm a Toasters says, I'm just a Twitch freeloader, but I have some Arduino Nanos and tons of random components. Will I be able to follow along? Certainly. Dr. S says, can we have an optional semester-long class collab project? Wait, you got it? What do you mean? You have an idea? Okay. Workshops, assignments, labs. Those are like the 3 types of exercises we do. So this is our tentative schedule. This is how I see things going. If I need to change anything, like I'll give you guys announcements. I'll let you know in advance. Something about due dates. So I'm going to post an assignment window on UB Learns for when you complete your workshop. And this is where you're going to submit it as an online student. So all online students, that'll be due by the 12th. So I almost have this rubric finished that you can compare your submission to the things on this rubric to make sure you have everything you need. So I'm going to get that out probably into this weekend. Yeah. Careful with the language in the chat. All right. What do I want to say about this? So yeah, you can just keep coming back to here. You'll see like when we're doing a workshop, when we're doing a lab, when we're doing an assignment. We all make a collaborative game that's similar to Hunger Games, and our final is a last man standing tournament, but only the winner passes the course. I mean, that sounds like a really fantastic idea, and I think that's what we'll do. Okay. So on the weeks where we have assignments, if you're an on-campus student, you won't go to lab. No. Yeah, okay, we won't do that. I'm joking. Okay. Okay, let's talk about grading. We haven't talked about that yet. So we have our 3 categories of assessments. So we have workshops. We have 7 of them. That's worth like 40% of your grade. The lab reports, 3 of those. That's going to be worth the next 40%. And I'm going to post a document that gives you the format of the lab reports. Astronaut says no final, thank God. Yeah, there's no final. No final. And then we have 3 assignments. That's worth 20%. And here's our grading scale. Is this class going to be hard? I think it's a challenging class. I'll tell you, historically, students do very well. A's and B's most of the time. So the vast majority of students are getting A's and B's. This class isn't here to kill you. I mean, we're just going to be doing some stuff each week. I think it's going to be a lot of fun. All right. Can I take a final exam? We don't have a final exam. We don't have a final exam. is online much harder than in person? No, I don't think so. Drulish says, are we assigned lab partners or do we choose? You can choose. I sent an announcement to the class that gives you a sign-up form. If you already know who you want your partner to be, you use that form. Just fill it out, put your names. Now, some of you may have no idea who you want your partner to be, or just the prospect of finding a partner might stress you out. So if you don't want to even look, that's okay, because I can put everybody who doesn't have a partner into a group eventually. D-Skid says, do most people not have experience with Arduino in this class? That's a great question. I think usually there's maybe 20% of students who have done some stuff with an Arduino before, but my experience is most students do not have experience with Arduino. So I'm kind of assuming that students coming in as a baseline don't have any experience, but you'll pick up a lot of experience. Can I be in a group by myself? No. So, I mean, I understand sometimes it feels more convenient to work by yourself, but, and sometimes it's very true also. But we're doing groups, and I think something that you have to learn, that I've had to learn, that I'm still learning, is that you can't do everything yourself because it's just not practical. So we need to start building skills to work with other people. And I think the earlier you start, so even if you're somebody who's just like, I really would, groups are more trouble than they're worth. I know that is the case sometimes, but we still have to navigate that. Okay, academic integrity. Let me mention this, okay? And you have to take this very seriously. Where this becomes a problem most of the time is lab reports. If any group shares content in their lab report, or if they plagiarize each other, you're just going to get 0 on that lab report. It's never worth it. And I will tell you, there have been cases in the past. There was a severe case where a student plagiarized every lab report, and they failed the course. So you will get a failing grade on your lab report if you plagiarize. If you make a habit of it, you're going to fail the course, and there's just no tolerance for it. Because I mean, this class, it's not here to kill you either. Like, I think it'll be challenging. I think you're going to have to put in work, but like I said, students who put in the work, most students get an A, get a B. So just, there's no reason to risk that. If you have a friend who's like, oh, I'm struggling, I got a lab report due tomorrow, help me out, can you do anything for me? The best thing you can do to help them is, you can help them like an instructor would help them with concepts, but you can't be sharing text, you can't be sharing code. It's going to get everybody in trouble. Yes, 1 lab report submission per group. And if you ever have questions like, can I do this, can I do that, can I share this, you can always ask me, and I'll let you know. Just say, nope, you're on your own. Yeah, I mean, that's the way it is, and it's really okay. Because even if you do very bad on one lab report, like you have a test coming up and you're like, look, I got to study for this test, I'm not going to finish the lab report. Then what is it? A lab report, we have 3 of them, each one's worth a little over 10%. Even if you don't turn in your lab report, that's not going to lead to you failing the course. So just be smart about it. Does each member submit the same one? So when you have a lab partner, we're going to make it a group submission on UB Learns. So you'll submit 1 lab report per group. Engineering is all about compromises. That's true. Even going through engineering school, just navigating your courses, you learn about compromises, and it's just like, well, sometimes I have to take a hit in one course That happens to all of us. It's okay. Once the lab report is complete, do you want us to submit it via UB Learns or print it out and take it to the next lab? It'll all be online. It says, liking your style of lecture. Nice job. I hope to have a great experience in this course. Yeah, I think I'm looking forward to this, guys. I think we're going to have a great experience. Cowardly Bean. Will the lab reports be like MAE Lab 2 where they end up being 3,000 words plus? No. No. They won't be 3,000 words. I can't give like a number right now, but I think they're... Because we do other things in this class other than labs, we're doing workshops, we're doing some assignments. I try to back off the... Okay, if you're on campus, these are your sessions, these are your TAs. Here's the contact information. We already talked about like the rules. You got to wear that N95 mask. You took lab 2 before lab 1? Whoa! Brutal. Okay. I know we're running out of time here. I'll get offline in a second. If you're on campus, it's important that you're on time. Check this out. If you're late for a workshop or a lab, that's going to start ticking off points on that workshop for you. Okay, so if you have something that comes up, like a conflict, some people might have a job interview or a doctor's appointment, let us know that you're going to miss your session. Wait, can you go back so I can screenshot the information? Sure. This is up on UB Learns as well, so you can always go back there. Actually, I'll just scroll past. You can go to UB Learns, get that info. So what is our next step? Showing up for our first lab session? Yes. If you're an on-campus student, your next step, go to lab next week at your scheduled time. Bring your kit. We're gonna give you a mask. You're gonna go through workshop 1. You're gonna get a lab partner. That's for on-campus students. If you are an online student, what's your next step? Start going through workshop 1. Go to, let's see. Check this out. Like if you haven't seen this, I made an example video of what your submission will look like. And like I say in the video, I made a short video just on my phone using these apps. You're going to have to do some time lapse. Do online students submit their workshops as a video too? Yeah, online students have to submit a video of them completing the workshops, but I want it to look a specific way. So make sure you read the directions and you check out this YouTube video. Well, we need to submit workshops by example or one total video. You combine it into one video using Adobe Rush. It's so easy. I'd never used Adobe Rush before, but it's just like drag and drop. So you can totally make the video on your phone, put all the clips together, and then export it to YouTube. Make a YouTube account, upload it as an unlisted video. That's the way I've been sending you guys YouTube videos. And I'll get a rubric up so that you know how you're going to be scored for these video submissions. So that's going to be up over the weekend. All right, guys, we're running out of time here. I really appreciate your attention. This has been a lot of fun. You guys are great. Do we need to have an N95 mask for next week's lab, or is it starting? No, next. You will need it next week. Here's the thing. We're going to give you that mask when you show up to lab. So you don't need to get your own. It's going to be there for you. Oh, I downloaded the zipped folder for the IDE. What do I actually install? Okay, let me. Let's go over here. Arduino IDE. So you go here. You go to software, Arduino. And then you just grab let's see. Like me, I'm running a Windows system. Or if you're running a Mac. Does it give you a zip? And then you just download, then you just donate $9 trillion. And then you download. But when you get it, let's see, I already have it on my computer. Oh yeah, just install the other thing, not the zip. Yeah, don't install the yeah, I don't think you need to do a zip file. Yeah, just download. It downloaded it. What? What's your opinion on the DP remakes leak? Wait, what is that? What is that? Pokemon Diamond and Pearl. Maybe. You know, I was thinking about getting Pokemon Sword and Shield, but I heard it's just not that great. I heard it's too easy. I mean, like I played Pokemon Yellow, I played Pokemon Silver. It's trash. Yeah, I wouldn't recommend. And I mean, it's like, isn't it like $60? I'm like, I'm not gonna spend that much. But I heard Diamond is okay, right? Or Plat. What, like which one's the best? Is this Doc's music? Dude, I love the Doc's music. This is like a synthwave thing from Soundstripe. Diamond is good. Platinum is best. Gen 4. Had it on the DS. Yeah, I played on the Game Boy Color. Pokemon Yellow on the Game Boy Color. Or wait, and Gold and Silver on the Game Boy Color. And I had friends who had this like magnifying glass attachment for the Game Boy Color. I need to look this up. Attachment Game Boy Color. Oh man, this takes me back. It was this thing. Oh man. You had a light attachment? Pokemon Go came out the summer my grandpa died. I remember downloading the app while he was sitting on life support. Pokemon Go has brought a lot of people together. Oh, do you remember the Game Boy Pocket? My brother had a red Game Boy Pocket. This one. Portable gaming holds a really special place in my heart. Like I said, I got the Nintendo Switch Lite for Christmas, and I love that thing. Game Boy Advance. Game Boy Advance. That one wasn't so pretty, though. Like this one, it's just ugly. Oh, this one. Yeah, I liked this. It was just like a little square. Wait, what about the what was that console by, I think it was Sega? This was like at the same time that the original Game Boy came out. And it was like this backlit like battery hog. No, not the Dreamcast. Wait, was it the Game Gear? This. Oh my gosh. I think it had like an hour of battery life. Good grief. Yeah, who wants to pay $250 for that? Do I play PC games? I used to be really into Warcraft 3 Frozen Throne. Baby Smoke, I can't believe this is what my tuition is going towards. Well, class is over, by the way. We're just hanging out. This is extra content. This is just gold. This is just gold on top of your education. Oh, yeah, Warcraft Reforged. Didn't go so well. Let's just say that. Yeah, this is just the icing on the top. Your education was earlier. My favorite game growing up was Horses on the PS2. GB Boy Color? What is that? I have no idea what that is. I'm like afraid to look this up because I don't know what is that? Oh, okay, it looks, what? What is this? Wait, what's your hair care routine? It used to be Pantene Pro V. Dr. S is 1v1 on Super Smash on Switch. Nice. I don't have Super Smash. Do you recommend any gesture sensor cars? I don't know about those actually. Why don't you have those cat ear headphones like a true streamer? Maybe that'll be my next purchase. Wait, is this like a knockoff Game Boy Color? Oh, I see. Oh, okay, the original wasn't back. This is a backlit one. Oh, okay. Gotcha. I see. Are you VODing this stream so we can watch them later? Yes. Yes. Okay, everybody. I'm gonna call it. I need to eat a late lunch. I haven't had lunch yet. But it's been great hanging out with you guys. I'll be in contact with you over Discord, over UB Learns, I mean. Peace. Have a great day. Have a great weekend. Thank you guys once again.